So we're back with the series of J advanced problem. So here is a good question. A force F is applied on the plank such that the hollow hemispherical shell is in equilibrium as shown in figure. The coefficient of friction mu is same between both, means mu is same at both the surface. Here the mu and here the mu both are same, and the plank friction is just sufficient to prevent the slipping. Okay, so you need to find out the force and mu for this case. Okay, so in the question it is clearly given that this mu is sufficient enough so that there is no slipping occurs. Okay, you are applying a force over here. Okay, and you need to find out these values. Okay, so let's draw the figure first. This is the figure. Actually, this mass m, this mass m. Okay, and you are applying a force at this position, and it is given that mu is same for both the surface. Okay, so now let's proceed. As it is given that there is no slipping, that means both of them will move with the same acceleration. So acceleration will be how much? A by m plus m. Sorry, there is a friction force also. This friction force acting over here will be F equal to mu into 2mg, right? So you can write acceleration as, so you can clearly write that F equal to mu into 2mg, and F minus F should be equal to 2m into A. So that is, this is the first equation because there is no slipping occurs. Now you are well aware that for this one, this is a hollow hemisphere. So for a hollow hemisphere, the center of mass is at r by 2 from the base. So this should be r by 2. So here this should be r by 2. Here it will be mg acting in this direction, right? So let's draw this separately and observe whatever we get from this hemispherical shell. Okay, so this is mg acting at this position, and as this is on a platform which is also moving with acceleration a, as I said, all this thing will move with acceleration a, so this platform is not static. So one pseudo force will be acting at the center of mass, that will be m into a. Okay, another one is normal force acting over here, and a friction will be acting. So as this is moving this way, so friction on this at the on this plank at the upper surface will be along this direction, and friction on the hemisphere will be along this direction. So friction will be along this direction, right? So this will be your this will be the scenario. Now you just do one thing, as there is no slipping, so just apply torque equilibrium about this position. So if you apply torque about this position, so whatever you will be getting is uh, see one thing. So as this is 37 degree, as this is 37 degree, so you can write this angle also 37, this angle is 53, and this angle is 37, right? So you can clearly write this angle is also 37 degree. Okay, so now if this is r by 2, so this one will be what? This one will be r by 2 cos theta, and this one will be r by 2 sin theta. So for mg, mg is acting this way, and this perpendicular distance is r by 2 sin theta. So mg into r by 2 sin theta, as we are equating torque or balancing torque about this point. So mg is this one, and this distance is r by 2 sin theta. Now this is ma, this one is r by 2 cos theta. So this one will be how much? This one will be how much? R minus R by 2 cos theta. So from here you can clearly write A is equal to G sin theta by 2 minus cos theta. And as it is not slipping, so you can write F should be equal to M into A. And F is what? Mu into N is mg. So mu mg should be equal to M into A. So mu is how much? A by G. A by G means what is the value of A you are getting? G sin 37. G sin 37 is how much? 3 by 5. 2 minus 4 by 5. G is 10. So you are getting 6 by how much you are getting? 6 by 5. So that is 5 meter per second square. So mu is equal to 5 by 10 equal to 1 by 2. You are getting mu, and as you are getting mu from here, so you can clearly write F minus F is mu into 2mg equal to 2m into A. So if you write the equation for the Planck, then F minus, let's say this is F1, this is F2, so F minus F1 minus F2 should be equal to m into A, and this F is ma, this F is ma. So you just put the value of F1 is mu into 2mg, this is ma, this is ma, that already comes to ma. You know the value of mu, 2mg and ma, all the values. If you put all this, you will be getting F equal to 100 Newton as your answer. So this was a good question in respect to JEE Advance. Okay, so that's all. Thank you.